Hello, my dear friends. You are welcome to JoeNewton online class. In this video, we are to solve this task on the board. Of course, this is physics. This question is taken from past question as we are preparing for JAMB or UTME examinations, as well as WAEC or WASC examination. Now, let's look at this question. By looking at this diagram on the board, we quickly know that the question is taken from electricity, or precisely from electric field, and that is capacitor, from the arrangement on the board. Now, we are given a diagram comprising three capacitors arranged in series, each 6 microfarad. Now, with 100 voltage supply, then we are asked to find the total energy stored by the capacitor. And of course, by looking at this arrangement, we can see that these capacitors are arranged in series connection. Do not forget that in series connection, first of all, for you to find the equivalent or the total capacitance, you have to use the formula of reciprocal, starting from the total. Then for that of parallel connection, for you to find the equivalent or combined capacitance, you just sum or add the individual capacitors. The capacitance of individual capacitors, when you add the sum, when you sum it up, you get the what? The total for parallel connection. This is opposite or contrary to that of resistors. Do not be confused in these two components. A capacitor is a device that stores electricity or charges, while the resistor is a device that offers opposition to the flow of what? Current in a circuit. And for that of resistors, the resistance of resistors, when in series connection, you do addition of the individual resistance, you get the total resistance in series, unlike the capacitor. But for the resistors in parallel, you take the reciprocal. So the operation or the calculation formula for resistors and capacitance are opposite or inverse in their formula. Okay, now for what we have on the board, before we could find the energy stored, we first of all find the total capacitance, because we are not given the quantity of charge, less for us to use the direct formula. Then solution for total capacitance, total C in series. What we need to do is this: 1 over C total, begin with reciprocal, is equal to 1 over C1 plus 1 over C2 plus 1 over C3, because we have three capacitors here, which is equal to 1 over 6 plus 1 over 6 plus 1 over 6. And of course, when we have the same numerator across, the LCM is 6. Our LCM is 6. So 6 divided 6 is 1. 1 times 1 is 1. So we have 1 plus 1 plus 1, giving us 3 over 6. So we can now see that our total capacitor, our 1 over C total, is equal to 3 over 6. Therefore, our C total will be inverse of 3 over 6, which is 6 over 3, which is equal to 2 microfarad. And do not forget that 2 microfarad is equivalent to 2 times 10 to the power minus 6 farad. That is it. That's 2 microfarad, because 1 microfarad is 10 to the power minus 6 what? Farad. Then the next thing is for us to find the appropriate formula for calculating the work done or the energy stored in the capacitor. Of course, the general formula, we have that the energy stored in the capacitor is given by W is equal to what? 1 over 2 QV. That is half Q times V, where V is the voltage, Q is the charge stored. But we are not given the charge stored in this capacitor. So we are going to use the alternate formula. The capacitance of a capacitor in its formula is given by C is equal to Q over V. This gives us capacitance of a capacitor. So we can now use the alternate formula that the work done, the energy stored or work done, is equal to 1 over 2 C V squared. How do we arrive at this formula? Since C is equal to Q over V, we can see that from here, Q is equal to CV. So in absence of Q here, when you put CV, it will become CV squared. That is it. So applying this now, we have 1 over 2 times our C is already 2 times 10 raised power minus 6 times our V is 100, 100 squared. Of course, this will give us 2, we cancel 2 here. We are left with work done is equal to 10 raised power minus 6 times 10 raised power 4. Of course, 100 square will give us 10,000, and 10,000 has 4 powers of 10, which is 10 raised power 4. By law of indices, you know that multiplication is transformed into addition of the powers. So minus 6 plus 4 will give us, this will give us 10 raised power minus 6 plus 4, which is equal to 10 raised power minus 2. Therefore, our work is equal to 1.0 times 10 raised power minus 2 joules. That's the work done or the energy stored in the given capacitors here. So we can now see that from the options here given to us, this is not the answer, this is not correct, this is not correct, this is the correct answer. So the correct answer is D. Very, very simple to calculate. Thank you. For more of these solutions, keep following me on my YouTube channel. Subscribe if you have not done so. Then click the notification button so each time I upload new videos, you'll be updated. Then for extra classes online through Zoom or Skype or any other means, you can reach me through my contact here. So we have engagement of online tutorials. Do not forget to follow me on my Facebook page also at JoeNewton Online Class.